This is Geometry, Chapter 12, Lesson 5, on page 510. All right, this whole lesson is on secant angles. So the question is begged, first and foremost, what is a secant line? A chord is a segment whose lines, endpoints lie on the circle, inside the circle, right? A secant line is a line that goes through a circle. All right, so there are two options for secant lines. If I have two secant lines, they can intersect inside the circle, or they could possibly intersect one another outside the circle. Make sense? See? They intersect, the two lines, secant lines, intersect at some point inside the circle, or they intersect at some point outside the circle. And they create secant angles. Those are secant angles. Those are also vertical, right? So they have to be the exact same. So if we were solving for this angle, and I knew the measure of the arcs that it intercepted, let's say the measure of this arc is 80 degrees, and the measure of this arc is 40 degrees. When the secant lines intersect inside the circle, you add the measure of their arcs and divide by 2. So the value of x is going to be 80 degrees plus 40 degrees divided by 2. So it's 120 divided by 2, which is what? 60 degrees. So the measure of that angle would be 60 degrees. So you don't have to know where that angle lies. Any place in the middle, inside the circle, not the middle. I don't want to say middle. So when secant angles, when secant lines create an angle inside the circle, you add their intercepted arcs and take half. Okay? Not so bad, is it? Now, when the secant lines create a secant angle outside the circle, let's say this is 80 degrees and this is 20 degrees. Here are my intercepted arcs, the 80 and the 20. I just subtract the farthest one minus the nearest one and divide by 2. So that's 30 degrees. So the measure of this angle is 30 degrees. Inside the circle, add the intercepted arcs, divide by 2. Outside the circle, subtract the intercepted arcs and divide by 2. So this is what we also just did in Algebra 2. So I gave a problem. It sort of looked like this, and then maybe like this. All right, those two lines are secants, right? I gave the measure of this one. I'm just going to make up numbers. We'll make up nice numbers. And I asked them, what's the measure of that angle? Well, you know what the temptation to do is? Take the 200 minus the 90 and divide by 2. However, that's not, this arc is not the arc that both of the lines intersect. It's this arc and it's this arc. But can I calculate this arc? Yes, because all the way around is? So I take 360 and I subtract? 290. I subtract 290. What's 360 minus 290? How many? 70. So then I take the 200 minus 70 and divide by 2, and what is that? 65 degrees. Okay, so everyone here should get that question right next year, a year from now, right? Of course, it'll be look a little different. All right. Okay, so let's work a few examples. What if I had two tangent lines and I told you this arc was 120 degrees? I'm going to start calling the angles theta. So how am I going to calculate this? Is the angle formed outside or inside the circle? Outside. So am I adding or subtracting the intercepted arcs? Subtracting. I'm subtracting. Okay, what am I subtracting? Jesse.
So would you subtract, I
know what you do.
What, Jaden? Go ahead.
Would you subtract 360 from 120 from 360?
Yes, and what is that? 360 minus 120 is 240. What's 240? Okay, so yes, I have to calculate this is 240 degrees. Then what do I do?
Then you subtract 120 from 360.
Then I do 240 minus 120 divided by 2. Got it? Nora, you're tricking with us? Excellent. Yes, Hannah?
Why did you have to find that?
Because I didn't know this intercepted arc. I didn't know the measure of this. I only knew the measure of that arc. And these lines are tangent. But this is where it intercepts. So it's this arc minus the close divided by 2.
So when you say farthest, do you mean the one farthest from the angle we're trying to find, or like?
Yeah, we didn't know the measure of the arc furthest from the angle. But we knew all the way around was 360. Okay, now what if I had this? Now I want to find the arc. All right, so Nora, just plug this in the formula and we should get it. All right, what goes in my numerator? What goes in my numerator? Right, but this is from this week. This is from this just a few minutes ago. Okay? All right, someone help Nora. All right, Therese.
You could say 44 equals 60, or equals x minus 65 over 2.
Okay, all right, so everybody pay attention. Everybody look at me, everyone. We're gonna label this x. So the arc furthest away minus the arc closest divided by 2 is the measure of the angle. I simply plugged it into the formula that I just gave you. Has everyone written this down? Okay, let's go back. If we have secant lines that intersect in the middle, we'll label that A, B, and theta. What is the formula? Jake.
It's A plus B divided by 2.
That's what theta equals. Got it? All right. Now, what if, on the other hand, we have lines that intersect outside. So now we have theta, okay? And now we'll call this C and D, the measure of those arcs. What is the formula here, Sarah?
C minus D over 2
equals theta. Exactly. Got it? That's the two formulas from this lesson. So what did we do? That's what we plugged in here. The arc far away, which we labeled X, minus that 65, which is closest to it, divided by 2 is 44. Now this is algebra. Right here. This is algebra. How am I going to solve this? What do I do first? Yes, Corinne?
Could you multiply both sides by 2?
Multiply by 2, both sides. Yes. That eliminates the denominator. So we're left with X minus 65 is 88. Finley, what do I do next?
Add 65.
Add 65 to both sides. So that the value of X is, what is that? 153? 153? All right. Let's do one more. Nora, I want you to help me do this one. You got this. You can do it. Just using those formulas. All right? All right, Nora, we're going to solve for theta. So can you help me know what the equation would be?
129 61 over 2.
Exactly. Good job. And did you already calculate that? All right, go ahead and calculate it. Everybody else calculate it too. Excellent, Nora. It's 34? All right, 34 degrees. Anybody agree? All right. All right, let's do just a few more. I want everybody to work on these. After I draw them, we'll label this one number 1. We're solving for theta. All right, start solving them. And then we'll come and just give the answer in just a minute. Have to make sure it can be seen. So my circles are not perfect. We'll call that 2. You working, Riley? Okay. 2, we're solving for the angle. 2, we're solving for the measure of an arc. All right, L, do you have one?
Yes.
What's theta?
59 degrees.
It is 59 degrees. Theta is 59. Everybody get that?
Yeah.
Is everybody understanding this? Feeling a little more comfortable, a little more confident? Yes? Anybody still struggling? Yes, I'd love to. All right, so it's outside, so what's the equation going to be? Yes. So what's 175 divided minus 57? Okay, here's what you should not do in your calculator. Okay, what is that numerator? 175 minus 118? Divide that by 2. Right. Okay, I think it was a calculator error. All right.
Calculator error? That exists?
User.
Yeah.
Well, okay.
Putting in the
User. Okay. No, here's the deal. If you don't tell your calculator order of operations, so if I put in my calculator, if I put this in my calculator, it's going to do 57 divided by 2 first, then it's going to subtract that from 175. If I don't tell it order of operations, so that's what I think she did. That'd be my guess, right? All right. Nathaniel, what's theta for 2?
115.
Does everybody agree? Yeah. Can y'all read these itty bitty numbers?
Yes.
What? These?
No, you can't.
115, 59, 110, 180.
He's looking
Or
at his
110, sorry, I thought one was 110.
I thought I wrote them small enough for you not to see. Okay. Who wants to answer number 3? All right, Corinne.
It's 180.
It's 180. Anyone have questions on this one? Yes. Okay. So, Corinne, what was your formula?
I did x plus 60 divided by 2 is equal to 120.
Correct. Whatever this arc is, plus that arc, divided by 2 has to equal the angle. Then what did you do?
I multiplied both sides by 2 and then 2 cancel out.
Yep, multiply by 2 so that you have x plus 60 is 240. Guys, this is simple algebra.
Wait, do you divide by 2 because it's...
No, it's that divided by 2, so you multiply.
Yeah, but you divide by 2 because it's 1/2 the angle? I don't know.
It's that divided by 2.
I'm asking why.
Why am I multiplying? Because listen, I'm taking the sum of the intercepted arcs, I'm dividing by 2.
Yes.
To move to the other side, I do the inverse operation of division, which is multiplication.
I was asking why you divided by 2. Not why you
Because it's inside, you always divide by 2. Inside or outside the circle, always dividing by 2. Inside the circle, you're adding the intercepted arcs dividing by 2. Outside the circle, you're subtracting the intercepted arcs dividing by 2.
It has nothing to do with the arc equaling 1/2 the angle, or the angle being 1/2 the arc.
No, because it's not inscribed.
Oh.
These are not inscribed angles. All right, so I'm glad you asked that so we can separate that, right, in your mind. We have central angles. We have inscribed angles. And now these are secant angles. All 3 different angles. 3 different types of angles. You got that? Everybody understand that? All right, so now we just subtract 60, and that's 180. Got it? Yeah. Jesse, what did you get for 4?
I'm not confident in my answer anymore.
Say it, Jesse. Go ahead. What is it?
Is it 100?
I got 100.
I didn't see it.
I got 100. Because it would have been x plus 70 divided by 2 is 85. You multiply both sides by 2. We have x plus 70 equals what? That's 170. Subtract 70 so that x is 100 degrees. All right.